Welcome back. Now talking about first angle orthographic projection. As we discussed earlier, that the first angle and the third angle, the only difference is the orientation. So we'll begin off with a note here, and in first angle orthographic projection, what you see from the left you draw on the right, and what you see on the right you draw on the left. This is in reference to the front elevation, and what you will see from above you draw below. So that's just a general rule that you should be able to grasp. So another thing that you should remember is that in terms of first angle orthographic projection, the viewer is placed somewhere like here. So the object is placed between the viewer and our work plane here. So if you were to shine a light or a flashlight, then the beam of light will hit this face, and thus the shadow will be projected to our opaque work plane. We have assumed our work plane in first angle orthographic projections to be opaque. These are the projection lines, these ones. So I hope that makes it clear. We can discuss further as we continue. So this is the orientation for first angle orthographic projection, where the front is directly above the plan, and the end is directly opposite the front, opposite the front. So the end can be either on the right or the left side of the front, depending on the model's directed front elevation or end elevation. So you can also use the arc method. This is the meter line method. So for the first cube that we did, as you can see, these yellow faces are our ends. So you are supposed to choose wisely which will be the required end. So for this example, the plan, which is pink for this case, as you can see, is here, and you will see that there are 3 rectangles comprised together to form the plan. And then for the front, you will see this sort of inverted T, which is this one, and assuming this the end elevation, the observer is assumed to be on this side, hence the end elevation will be on the right side of the front, assuming you are facing the screen. So for this example also the same principle applies. So if you are to be at the top, you will see the red faces, and you will also be able to see part of this blue face if you are directly above this model. So our plan will be this will be our plan. And then if you are to be directly at this side, which will be the front, then you will be able to see only the green faces, and this is our front. And if you were to be directly on this side, which is we have assumed is our end side, then this will be what you will be able to see. And as you can see, because we have assumed that the observer is on the left side of the screen, then the end elevation will appear on the right side of the front elevation. The same applies to this model. You can confirm that with me, and you can see that the red represents the plan, the red faces. The pink and some slight parts of green will also represent the front elevation, while the green part and this part of red slope will represent the end elevation. As you can see, the end elevation is still on the right side of the front elevation, because the observer is assumed to be on the left side of the because the end elevation is assumed to be on the left side of the screen. So for circular features, the principle is the same. So we just introduce center marks and center lines. So the principle, the plan goes below the front, and as we discussed earlier in third angle, you do not, for circular or especially cylindrical features, you do not need to draw the end elevation, because the end elevation and the front elevation are similar. So this is the example that we use to demonstrate for feature having cylindrical parts. And as you can see, for the plan, we will see the green parts and part of this groove here, and the bottom of this groove too, as depicted here on this plan. And then for the front elevation, you will see this red face too, and some part of this yellow face, just as shown here. And for the end elevation, which is on the right side of the front, then you will see this yellow part, which you will view as a rectangle, and this also red part of the cylinder, which will also view as a rectangle, as shown here above. So let's discuss the differences between first angle and third angle orthographic projection. And for the first angle orthographic projection, the object is placed in the first quadrant, while for third, the object is placed in the third quadrant. For first angle also, the object lies between the observer and the plane of projection, while for third angle, the plane of projection lies between the observer and the object. So for first angle, the plane is assumed to be, the plane of projection is assumed to be non-transparent or opaque, while for third angle, the plane is assumed to be transparent. So in first angle, the plan comes below the front elevation, and the view of the object is observed on the left side is drawn on the right side of the elevation, while in third angle, the plan comes above the front elevation, and left hand side view is drawn on the left hand side view of the front. So that's it. Now let's discuss projection symbols. So in terms of in engineering drawing, you need to communicate after placing your drawings to the technician who will produce the parts. So to communicate to the technician about which method you have used, you will use these symbols. This is the symbol for third angle orthographic projection, while this is the symbol for first angle orthographic projection. So how do we come up with these symbols? So you will just assume to have a conical flastrum, and if you were to view the flastrum from third angle orthographic projection, then this will be the plan, and this will be the front. So this is what makes our symbol, or either the plan, and the front, depending on the point of view. This is from the the first one is for when the viewer is above, and the second one is when the viewer is below the flastrum. So the same applies with the first angle, and as you can see, this is for when the viewer is below the flastrum, and this is when the viewer is above the flastrum. So these are the accepted orientation. You can either draw them while they are aligned horizontally or vertically. all are acceptable. Just be sure to use the symbol depending on the space requirements of your drawings. So these are the dimensions for drawing, and sorry, these are the dimensions for drawing the orthographic projection symbol. So I hope you will be able to understand and just apply the principles. So we'll talk about in the next session we are going to talk about hidden lines and finish up on the topic.